This is Algebra 3, Unit 7.3. We were talking about statistics. Here's what we talked about last time. This is the inverse normal. If you are given a probability or area under the curve, and you have to find the corresponding x value, you want to use inverse normal. So that leads us to our next topic, percentiles. A percentile divides a data set into, you guessed it, 100 equal parts, just like a percentage. As a small example, I'll draw a bell curve where the mean is directly in the middle. And that would mean that mean represents the 50th percentile. If I was somewhere below the mean, let's say at the 30th percentile, that would indicate that this area here would be 0.3. So that shaded area would be 0.3. And so you can break up this bell curve into 100 parts, where each is a percentile. Assume that IQ scores are normally distributed with a mean 98 and standard deviation 7.9. It does turn out that IQ scores in real life are actually normally distributed, so this is a good example. What IQ score would be in the 75th percentile of all test takers? The first thing I'm going to do, just like my other problems, is to draw a bell curve. The mean is 98. The standard deviation is 7.9. 75th percentile, now that's not a score, that's a percentage. So the 75th percentile is going to be somewhere above the mean, because 75% of all people will be below that score. So this shaded region right here is 0.75, and we need to find the x value. That x value or score will be given by inverse norm of 0.75, comma, mean, comma, standard deviation. Now I am going to pull up a graphing calculator or some other technology, and I'm going to press second, distributions, inverse normal of 0.75, comma, mean, comma, standard deviation. We're interested in the shaded region to the left, so that means I'll leave it as left, paste, and enter. And I got a score of 103.3. You can get a score over 100 on the IQ test. All right, next question. Suppose that the mean IQ score is 98 with a standard deviation 7.9, so same parameters. What score is needed to place in the 80th percentile? Again, 80 is not a score, it's a percentage, so that's going to be above the mean. Some score x with the shaded region to the left, and that's going to be 0.8. Inverse normal of 0.8, comma 98, comma 7.9. Let's bring up the calculator again. Inverse norm of 0.8, 98, 7.9, to the left, and I got a score of 104.6. At this point, please pause the video, try example 2b on your own, and see if you can come up with the score that would put somebody in the 15th percentile of all test takers. All right, here we go. I draw my bell curve with a mean 98, standard deviation 7.9. 15th percentile is going to be below the mean. That area is 0.15, and so x should be inverse norm 0.15, comma 98, comma 7.9. Hopefully you got 89.8. Couple more. Suppose that the mean IQ is 98 and standard deviation 7.9 again. If you score a 103, what percentile of all test takers would you be in? This is not an inverse normal question. This is a regular normal CDF question because we are given the x value instead of being given the percentage. But the process is the same. .103 would be above the mean. Percentiles would be to the left, so we're interested in to the left of 103. Therefore, the percentage would be normal CDF of lower limit. Remember that the lower limit goes on forever, so let's just pick a really big negative number up to 103 with a mean 98, standard deviation 7.9. Back to the calculator. Now for this one, I will press second distributions and pick normal cumulative distribution. The lower limit is some really big negative number up to 103 with a mean 98, standard deviation 7.9. And there you have it. That shaded region would be 736. We'll round it up. And so 73.7%. You would be in the 73rd percentile. 73rd.7. In 2002, there's a good baseball application. The average payroll for an American League baseball team was $69.4 million, with a standard deviation of 28 million. If the New York Yankees payroll that year was in the 98th percentile of all teams, how much was their payroll? And so we're assuming that the salaries are normally distributed with a mean of 69.4 million, standard deviation 28 million. The 98th percentile would be way up here because the Yankees always pay their players tons of money and they also win lots of baseball games. So that area is 0.98. And so inverse norm of 0.98, comma 69.4, comma 28. To the calculator one more time. inverse norm of 0.98, mean standard deviation, and to the left. $126.9 million was the estimated Yankees payroll that would put them in the 98th percentile of all baseball teams. Try checking that value online and you will see it's probably pretty close. So inverse normal and normal distributions are a good way of estimating probabilities and data values. There you have it. Please comment on this video in order to earn credit, and then have a nice day.